Hey there, Mr. Sutton here with the AB Calculus 3.5 Part 2 homework solutions on quotient rule. On this problem, I'm given a table with values of f and g at x equals 3, and we have the k function, which is f of x over g of x. We want to figure out k prime of 3. Well, I've got a quotient, and there's no other way to do this, so I'm going to have to use the quotient rule, u prime v minus uv prime over v squared. So let me set up my box and ribbon to keep things organized. I've got my numerator and my denominator, so f of x and g of x right here. And then down below I have their derivatives, f of x and g prime of x. Now if x equals 3, because we're doing k prime of 3, what do these things take on values of? Let me put that inside another box. So f of 3, that's in the table, that's -1. G of 3 is in the table as 2, so careful, make sure you're putting the right stuff in there because they gave us the original functions and then the derivatives. Sometimes they change it up from that. Now we have f prime of 3, which they told us was 5, and g prime of 3, which they told us was -2. Using my ribbon to put it all together, I've got 5 times 2, that's the u prime v, minus -1 times -2, so that's a whole bunch of minuses. So ultimately 3 minuses is just going to give us 1 minus. Probably not a bad idea to simplify as we go here. And then all of that divided by v squared, so that's 2 squared in the denominator. Have to simplify a bit more to get one of these answer choices. So this is going to be 10 minus 2, which is 8. All of that over 4. 8 over 4 comes out to 2, which gives us answer choice C. On this problem, we're trying to find the derivative of this quotient. So there's 2 ways to do this one. You can do this with or without the quotient rule. You're allowed to do this without the quotient rule because you just have a monomial in the denominator. If this were a binomial or some other crazy function, then this first method I'm going to show you would not work out. But since we have this situation, we always like to simplify when we can. So let's simplify and then take the derivative. Going from left to right and dividing each of the things in the numerator by my denominator, I've got 3 x to the third, if we subtract those exponents, minus 2x, and then this will be plus, this will be x to the -2. I might as well make this x to the -2 if I actually want to make this something that I can use the power rule on. Now going left to right and using the power rule, we've got 9x squared minus 2. And then over here, this will be minus 2x to the -3. And that one's done. Now this problem also could have been done using the quotient rule. So here's that again, u prime v minus uv prime over v squared. And then let me use my box and ribbon to organize this. So I've got my numerator here. That's this trinomial that I'm not going to bother saying out. And then denominator, that's going to be just 4x squared in my v spot. And now their derivatives, we've got u prime down here, that's going to be 60x to the 4th minus 24x squared. And then v prime, that's just going to be 8x. Using my ribbon now to put everything together, we've got the lower left here times 4x squared. And then we're going to be subtracting this huge trinomial times 8x. All of that over 4x squared squared. Again, I'm not going to simplify if they're not requiring it. Let's just leave it at that and call it a day. For this problem, I want to figure out the derivative of this quotient here. Now, since this is not something I can just reduce to a polynomial and use the power rule on, I am going to need to use the quotient rule. So there's the quotient rule, u prime v minus uv prime over v squared. Let me set up the box and ribbon so I can organize this. My numerator, I've got 3x minus 2, and I have my denominator, 2x plus 3, and I have their derivatives, which are 3 and 2, respectively. Doing my ribbon now to put it all together, I've got 3 times 2x plus 3, so that's going to be the u prime v, minus uv prime, so that's coming this way now. That's 3x minus 2 times 2, and we're subtracting all of that. All over v squared. This is the other reason I write out this formula so I don't forget this v squared. So that's 2x plus 3 quantity squared. And just kind of looking at the setup of the problems, you'll notice there's a 2x plus 3 squared in all the answer choices. So you at least know you're on the right track using this. Now we actually are going to have to simplify, though, because all the answers are simplified. So distributing things out, I've got, let's see, this will be 6x plus 9 for that first parentheses. And this next one, this is going to be negative 6x plus 4. So I've got 6x minus 6x. Those are going to cancel. 9 plus 4 is 13. And this is about as simplified as things are going to get. So 13 over all that stuff, positive, is going to be choice D. For this problem, I have a quotient here, and I'm trying to do f prime for this thing. Now, at least look to see if you can simplify this, right? I mean, the numerator, you can factor it, x plus 1 and x plus 2. But that's kind of a dead end because x plus 3 is not going to cancel with either of those. So we go to our quotient rule, u prime v minus uv prime over v squared. And let me set up the box and ribbon for this. So I have my numerator, x squared plus 3x plus 2. And now my denominator, the x plus 3 over here. And their derivatives, which are going to be 2x plus 3 and, well, just 1 for that other one. So that's going to be nice. All right, using my ribbon to put it all together, I've got 2x plus 3 and x plus 3. Make sure you have parentheses around both of those. Minus x squared plus 3x plus 2, all of that times 1. So you don't really have to bother writing the 1 there. You do need the parentheses around all of this, though, because we're subtracting. And then we have the v squared down here. That's x plus 3 quantity squared. And we see that in a lot of answer choices. So there's a good chance that's not going to cancel out, but you never know. We have to simplify this now. So we've got, well, let's distribute out this first one here. So this is going to be 2x squared plus 6x. And then we'll have, let's see, 3x plus 9. And now just distributing this negative to this whole parentheses, negative x squared minus 3x minus 2. A lot of like terms to collect here. The x squareds, let's start there. We've got 2x squared minus x squared is just 1x squared. And then 6x plus 3x minus 3x, well, those 3x's are canceling, so that's 6x. And for the constants, we have 9 minus 2, which is 7. And this is also factorable in the numerator, but it's not going to cancel out the denominator. So we're just going to go with this for our answer, choice C. For number 5, I've got this function x minus 1 over x plus 1, where x does not equal negative 1, and I want to find f prime of 1. Since I can't simplify this at all before taking the derivative, I might as well use the quotient rule on this. So u prime v minus uv prime over v squared. Let me set up my box and ribbon for this one. So in the top, I've got x minus 1, my numerator. Over here in the top right, I've got x plus 1. Down below, we've got their derivatives, which are 1 and 1, respectively. And then let me just go ahead now and actually plug in 1. I could actually ribbon this thing and write something out here and plug in, but I think it's faster if I just do it all inside the box here. So if x equals 1, here's what my box now looks like. 1 minus 1 is 0. 1 plus 1 is 2. And we still have constant values of 1 and 1 down there. All right, doing my ribbon. I got 1 times 2 minus 0 times 1, all of that over 2 squared. So this is just 2 in the numerator over 4 in the denominator, which gives us 1/2. Choice D. For number 6, we're asking what the instantaneous rate of change at x equals 2 is for this rational function. Since I can't really simplify this anymore, I'm just going to take the quotient rule of this and then plug in 2 for x. So quotient rule, there it is, u prime v minus uv prime over v squared. I'm going to use the box and ribbon approach for doing this. So I've got my box, I've got my numerator, x squared minus 2. In the top right, my denominator, x minus 1. And down below, their derivatives, 2x and 1 for each of those. And I'm just going to actually go ahead and plug in 2 inside the box here. So if x equals 2, let me rewrite my box now. We've got 2 squared minus 2, so 4 minus 2 is 2. 2 minus 1 is 1. 2 times 2 is 4, and then this is still a 1. Using my ribbon, I've got 4 times 1 minus 2 times 1 all over 1 squared. That's 4 minus 2, which is 2, over 1, which is still 2. Grand total of 2, choice D. Number 7 is a fun one. We've got this function x over x plus 2. We want to know what points on the graph of f have the property that the tangent line at that point has a slope of 1/2. Well, when we're talking about the tangent line, we're talking about the derivative of the function. So we basically need to figure out the derivative of this function and set it equal to 1/2 and solve for the x values and maybe plug those back in for y values too while we're at it. But let's start with the first thing, finding the derivative of this function. Since I can't simplify this, I'm going to have to use the product rule. So u prime v minus uv prime over v squared. Let me set up my box here. I've got my numerator x, denominator x plus 2. Their derivatives are both 1, which is nice. And let's go ahead and do the ribbon now. We've got 1 times x plus 2 minus x times 1 all over x plus 2 quantity squared. So that's just really x plus 2 minus x, which is just 2. So there's my derivative. And the reason I simplified this is because I know I'm going to have to solve this for places where it equals 1/2. So it might as well be simplified to make that solving easier. Now I'm going to set this equal to 1/2 and solve for x. So I'm going to cross multiply here. This will be, let's see, x plus 2 quantity squared over here, which I can expand to x squared plus 4x plus 4. And then crossing the other way, I get a value of 4 on the other side of the equation. This is a pretty straightforward quadratic. Let's just subtract 4 from both sides. And now we can just factor out an x here. So that's x times x plus 4, giving us the two x values, 0 and -4. Now there's only one answer choice actually that has both of those as x values, and that is choice C. If you're kind of leery about just picking choice C without knowing the y values, it doesn't take too much longer to plug these in. So you have 0 over 0 plus 2, which is 0. So 0, 0 is a point. And for -4, you've got -4 over -4 plus 2. -4 over -2 comes out to 2, which gives us choice C. For this problem, we're given a table for the differentiable functions f and g, and we want to figure out h prime of 0. So h is just f of x over g of x. This is one where we're going to have to use the quotient rule because there's no way to do this without the quotient rule by simplifying. So let me write that out. U prime v minus uv prime over v squared. So now, in particular, we're going to use the box and ribbon to organize this information. So I've got f of x and g of x, my numerator and my denominator, and their derivatives, which are f prime and g prime. Okay, so let's actually plug 0 in now, and I'm just going to do this inside the box and ribbon. So I've got f of 0, which I can read right out of the table. That's going to be 3. G of 0 is going to be 2. F prime of 0, also in the table, that's 4. And then g prime of 0, that's up here, that's pi. Putting all this now in my formula, using my ribbon to do that, I've got 4 times 2 minus 3 times pi all over 2 squared. This is the v squared down here. And just to simplify so I can match one of the answer choices, 4 times 2 is 8, 2 squared is 4, so we have 8 minus 3 pi over 4. Can't really simplify that much more, and I don't have to because that gives me answer choice A. On this problem, I'm trying to figure out f prime, given that f is 5 minus x over x cubed plus 2. There's no way to do this without using the quotient rule. I can't really simplify this otherwise. So let me write out that quotient rule, u prime v minus uv prime over v squared. And let me do this with the box and ribbon just to keep things organized. So I've got my numerator, 5 minus x, my denominator, x cubed plus 2, and their derivatives. Derivative of 5 minus x is -1. Other derivative here is going to be 3x squared. Putting it all together now using the ribbon, we've got negative parentheses x cubed plus 2, so careful with that, minus parentheses 5 minus x times 3x squared. This is the uv prime over here. All of that divided by v squared, so x cubed plus 2, whole thing squared. Now it looks like I'm going to have to simplify this to match one of the answer choices. I've at least already taken the derivative, but I'm not quite there yet. So let me distribute. This is going to be negative x cubed minus 2 for that piece. Denominator we're going to keep the same. There's no reason to multiply this out because all the answer choices have this as a squared parentheses. Let's just simplify this other part. So this is going to be essentially negative 3x squared times 5 and negative x. So we've got negative 15x squared. And then minus minus, this is going to be plus 3x cubed. Let me collect like terms now. I've got a negative x cubed and a positive 3x cubed. So that's 2x cubed altogether. Minus a 15x squared minus a 2. I'm just going to put things in decreasing order so that I can match the answer choices more easily. And if I look at my answer choices carefully, it looks like that's going to be choice C. For this problem, we want the slope of the line tangent to the graph of this function when x equals 1. So you're basically asking for y prime of 1, the derivative at 1, which means we need the general derivative of this thing. We're going to need the quotient rule for that because there's no way to simplify this. So that's u prime v over, or minus uv prime over v squared. Let me set up my box and ribbon to keep things organized. So I've got my numerator here, x squared minus 2. Denominator, x squared plus 1 will go over here. And their derivatives, which actually end up both being 2x. Well, that's kind of nice. All right, using the ribbon to put it all together, we've got 2x times x squared plus 1. And actually, before I do that, let me just plug 1 in directly in here. That's actually a pretty good idea. That'll save me a lot of needless simplifying over there. So if I have an x value of 1, let's see what this actually comes out to. So then x squared minus 2, that's really 1 squared minus 2, which is negative 1. X squared plus 1, that's just going to be 1 squared plus 1, which is 2. 2 times 1 is going to give us 2 down here and also down here. So now using my ribbon to put it all together, we've got 2 times 2 minus negative 1 times 2. So that'll be plus 1 times 2. And then all of that divided by 2 squared. This is the v squared here. Let's simplify that to get an answer choice. So we have 4 plus 2 is going to be 6. So we have 6 over 4, which reduces to 6/4, 3/2. There we go, choice E. On this problem, we're trying to find the derivative of uv over w. So this is really just a big quotient rule with a whole bunch of letters in it. Let's start by setting up our box and ribbon. So I've got my numerator, uv, and my denominator, w. Now I need their derivatives. Derivative of uv, this is just literally the product rule, u prime v plus uv prime. And then derivative of w is w prime. Multiplying it all out with the ribbon now, we've got lower left times w minus upper left times w prime, so uv w prime. All of that over w squared. And at this point, you might be able to get a few answer choices eliminated. So we have a minus uvw prime. That's not going to change after I simplify. The only ones with a minus uvw prime are going to be, let's see, choices B, E is still in the running, and it looks like C is a little bit suspect here. Actually, yeah, C doesn't work because we have a positive uvw prime there. So it's down to B versus E. All right, let's distribute this w now. This is going to be u prime vw plus uv prime. I said u prime v, right? Yep, and then uv prime w. Too many primes in this. Now looking at our answer choices, we had it narrowed down to B versus E. Looking at these, nothing is going to cancel out. The prime is in a different spot on each of these. So that's going to be choice E then. Now D looked very similar. You'll notice we have the u prime, the v prime, the w prime, just like this. But D, we had a positive instead of a negative for that last term. So that's why this is answer choice E rather than D.